The goal of Deimos is to provide a test bed for other reactor concepts.
Engineers at Los Alamos National Laboratory are reviving a capability-critical experiment in reactor-like configurations with a reactor-type fuel that hasn't been used in more than 40 years. This is a critical step toward developing the next generation of nuclear reactors. By reestablishing advanced nuclear fuel testing capabilities long thought dormant, the lab is accelerating progress in advanced reactor technologies.
To license a new reactor, we must ensure the new nuclear fuels achieve criticality and also achieve shutdown upon conditions.
One of the most promising fuel candidates is HALEU triso fuel, which is a powerful combination of high-assay, low-enriched uranium in tri-structural isotropic fuel particles. This type of fuel won't spread contamination in adverse scenarios and allows reactors to produce more power in a smaller footprint.
Triso fuel is inherently safe fuel. This is why the fuel of Deimos is so important. This will keep us safe and allow nuclear to be the driving force in our power needs going forward.
The fuel used has a higher enrichment and can be used longer than typical commercial fuel, which means that microreactors, if designed correctly, could be operated for up to 5 to 10 years.
The reason this is important is that advanced reactors can be put into a microreactor, operated, and then eventually just disposed without the need for lots of refueling, as seen in our commercial fuel cycle.
But testing HALEU triso fuel isn't easy. After 3 years of intensive design work, Los Alamos engineers launched a groundbreaking experiment known as Deimos, named after one of Mars's moons. The team used lessons from an earlier experiment called Hypatia to improve the Mars platform. And by reestablishing the assembly at the Nevada site, the team created a platform that enables advanced reactor developers to support their experiments using high-assay, low-enriched uranium. But Deimos goes far beyond previous designs, with a fully reconfigurable core that can handle nearly any fuel type, speeding up the design and deployment of new nuclear technologies.
What we do here at NCERC is to take systems critical, so that means a self-sustaining nuclear reaction. The Deimos project was really our first foray into doing a more reactor-type testing. And so it's been very interesting to go in a new direction that supports the country's need for additional electricity by being able to test small-scale reactor concepts. Even if they're just a fraction of the scale, they'll be ultimately to contribute to that mission.
The Deimos experiment, which began in August 2024, generated critical data to validate system behavior and pave the way for future tests already in planning.
So by establishing this test bed, industry can bring in and test their fuel and all these different fuel options that come along.
The implications reach far beyond the Los Alamos National Laboratory. Microreactors will one day provide reliable energy to remote communities, support disaster relief efforts, supply data centers, or power military installations.
Deimos has become an integral part of the nuclear energy renaissance, which is the drive to create more nuclear power to achieve the energy needs of today and the future.
By reviving long-unused testing capabilities and pushing the boundaries of nuclear engineering, Deimos is helping shape the future of safe, reliable, and scalable power.